In review, that cylinder is 1 3/8 long and the ports are 9/16 from the center. So this is 1 3/8, and then I found the exact center, and that could also be found by the diagonal method. And again, those port holes, yeah, port holes. I saw some of those on the Alabama. 9/16 from the center. And those two port holes are going to be 3/32 in diameter. The center hole for the 540 needs to be tapped. You model makers, make yourself a set of these, handiest things in sliced bread. For a 540, the tap drill size is a number 38. So the center hole there is a 38, and the two outer holes are 3/32. Let's go over to the mill and do as so. Now that could be done in the drill press, but that does not assure you of getting that threaded hole in the center perpendicular. Back at the mill, and I've already used the wiggler here and found the exact center of the work in both the X and the Y axis, and then I have set my digital readout for 0, 0, because I will drill the center hole, and then I will move 9/16 both to the left and to the right and locate the other ones, which are 9/16, which is going to be 0.562 thousand. So now I'll put the little center drill in, and using the digital readout I can move back and forth, or I could drill the center hole there and then tap it, then move one way and the other. So you got, you know, two different ways of doing it, but it's very accurate to move back and forth if you have a digital readout. I'm now center drilling, locating that one, and then I'll move 562 thousandths this way. And as you can see, there wasn't even any need for me to locate those. I could have done all of the layout here, but I wanted you to see it. And then 562 I moved here. And my 3/32 bit over on the bench. I'll be right back. That's the 3/32 bit. I might have misspoke. And I'm going all the way through and breaking into the cylinder, just the one wall. I'm not going all the way through the piece. Quickly move it down here. You can see how handy that digital readout is, and how accurate. Take your time, do not break a drill bit off. I'm into the cylinder hole. Now I'll back it up. Right into the middle. That's back to 0. And lock the table. Now I'll change drill bits and put in the number 38 so that I can tap it, and I'll do that off camera. I just drilled that hole on number 38, and I went all the way into the cylinder. Now that could be a blind hole not entering the cylinder, because we do not want that to leak, but I will Loctite that stud when I put it in there, and I do not like to deal with a blind hole when I tap. Now some of you have not followed my videos, you haven't seen me do this before, but this is a hand operation. The machine will not be turned on. I have not moved the table. You absolutely do not want to lose your location. There's a little dead center, homemade dead center, located in the chuck here, and when I bring that down into the end of the tap wrench, there's a center hole there, that will guide the tap, assuring that I'm tapping straight and getting a hole that is perpendicular, and I talked about that a few minutes ago. And I am gently pulling down on the quill with my hand to keep pressure up against the tap holder, releasing it a little bit to back it occasionally. Do not break that tap off. A number 5 is this is tapping real easy. That must be a pretty sharp tap. And I'll go in all the way. That's a taper tap. I'll go in quite a ways to overcome the taper on the tap, and then this piece is done, at least for now. The cylinder is done for now, and I will run a hand reamer through there to remove the burrs, always turning clockwise, never counterclockwise, and that's going to score it a little bit. I'm probably going to have a few marks in there, tool marks, but I just have to live with them. It really won't affect the performance. One other thing that needs to be done, and that is to put these chamfers on there. That's strictly for appearance, but I do believe I'll do that. It just makes it look a little less cloddy. I'll do that later on, but for now, then, after cleaning this up, I'll go ahead and make the head. Simple enough little operation, so let's do that now. I need to do something easy before supper. I'm working on the head, and it's already half done. This is 3/4 brass. It was 5/8 brass on the other sample, but this is a little bit bigger. This is 3/4 brass. I've already turned a step on it. 1/2 inch in diameter and about 3/32 long. Never mind that hole in the end. That was just left from another job and doesn't matter at all. And as you can see, it fits just right, and I'm going to hold it in there with Loctite. Now if you want to use bolts, you sure don't have much room to do it. As you can see, very little room to use bolts, so that's why Loctite or press fit is the name of the game here. And now I will change tools, put the parting tool in, and just part it off so that the head is about 3/32 thick. I put a little chamfer. I'll start the cut, put a little chamfer on it, and then part it off. Off camera, of course. There's the head. Now I never get a very good finish when I part it off, and I still got the little nipple there, so my treatment for that is simply to take it to some emery cloth like this. Now this could be held in a 3-jaw chuck, but just barely. It probably would fly out. There's not much to hang on to. A collet would hold it better, but it doesn't really matter, so I'm going to just dress it up like this. It's too small to put on the belt sander, but that'll clean it up nice. Maybe just a little bit more, and then I'm done. And you can see that it'll fit. Let's see if it fits in one end better than the other. Pretty nice fit. You can see that I made it out of larger stock than what I did on this one. Boy, I've got a heck of a glare there. But neither one has room for bolts, as you can see. The next step is to make the bottom head. Actually, I don't know if it's a head, but it's the bottom portion of the cylinder that allow the piston rod to slide through it. And that also is made of 3/4 brass. And I will already, in the lathe here, turn down the end of the brass, the 3/4 brass, so that it's 5/16 in diameter and 1/4 inch long, so that it in fact looks like this. I'm making 2 of them. Then I cut it off, and that's about 1/4 inch thick. Now I'll remove this, chuck up this piece. Now the order of operations here is essential. Do not change the order of operations. Chuck that up. Now I'm going to face it, center drill it, ream it 1/8 of an inch, and then turn the step on it right here. The same as I turned the step on this piece, which is 1/2 inch in diameter and about 3/32 long. So in some ways, matter of fact in all ways, this end here will look just like this. Now I'm going to do that off camera because it's kind of routine. There we go. And it fits right into the bottom of the cylinder. It's most essential on this piece that the 1/8 inch hole be concentric with the 1/2 inch step. If not, the piston is going to bind. So be careful when you make this so that that you get those concentric. And if you follow those steps and you have an accurate lathe, they should be pretty darn accurate. Well, that's enough for today. Got the head and the bottom. Now tomorrow I'm going to fit up the stud that will hold this into the hole there, like that. I'm going to cut this to length because now I can determine how long this needs to be in relationship to the center of this. Then I'll make the piston rod, and the rod end. So coming right along on the project, so that's enough for today, and I'll see you in the morning. I love the smell of cutting oil in the morning. Howdy, it's TUBALCAIN again, and it's yet a new day. And I'm going to get started here on the engine. Sometimes I gotta think, what did I do last? But well, I got a mess on the workbench, and sometimes I like to clean up before I start or at the end of the day, but I need all this stuff, so it's going to stay there. Something interesting before I get started here. If you did not see this video here, TUBALCAIN takes a field trip to Grizzly down in Springfield, Missouri. Today it will turn 20,000 views, and the only reason I tell you that, and go back and look at that if you haven't seen it. I bought this granite surface plate there one year, quite cheap, and then there was no shipping. But I had a nice conversation with a man there that worked there, and there was only about 2 other customers in the store. It was 9 in the morning, and that place is just mammoth. But I said to him, how would you feel if 20,000 people came through this store? And I don't know where I came up with that number. It was pretty arbitrary, and I didn't get a rise out of it, but I thought I would. And but anyway, today, the 20,000th one, or first, person will come through there. Not all at once anyway, but it is a lot of people that go through the store, and I don't work for them or anything like that, but it's a fun place to go. That was a smoke alarm that went off. That was quite annoying. My wife burnt the bacon a little bit or something. I got to go up and eat. But I already trimmed the end of this main bearing. I told you I was going to do that, and I determined that by putting the cylinder into place here, like that. And lining up that boss with the pin. So in order to do that, you know, it's so hard to saw this. I took the engine off the base temporarily, and I just put it up against the belt sander and sanded that down to my layout line, and then deburred it. That worked real well. So that's done. Next I'm going to make 2 1/8 inch studs. One will be this little stud here that's threaded on both ends, and then the other one will be this stud here that connects the piston with the well, it's the connecting rod is what it is. But use 1/8 inch rod and a 540 die. Now, again, a number 5 is 1/8 inch. That's the beauty of it, but I do understand that those taps and dies are hard to find as hen's teeth. You're certainly not going to find them at a local store, but hopefully you got them. Otherwise, you're going to have to change the dimensions and use something else. But if you use a number 6, you're going to find this an odd decimal size. But take your 1/8 inch brazing rod or brass rod, whatever you have, and I always start by squaring up the end and chamfering it real quick, just like this. And that's done and it's ready to thread. Let's go over to the Atlas lathe and I'll show you how I do that. Here I am at the smaller Atlas lathe, and the 1/8 inch brass is in the 3-jaw chuck, and the 540 die is in this little die holder held in a chuck, free to slide. I put the machine in back gears, and I've got a mark on there if you can see that, and use a little oil. And all I'll do is force the die up against it, and I'm watching it at the same time till I get to the black mark, and then I'll stop the lathe. I do not have a reverse on this machine. Watch this. I'm up to the line, and then in order to back it off, since I do not have a reverse, you probably do, I'll just spin this off. And that end is done already. Now I have to cut the piece off and thread it from the other end, and here's the 540 die, and that's just a little homemade die holder. But do not attempt to do this free-handed in the vise just with a hand die, because you're going to get a crooked thread. This assures you that it's a straight thread. There's a little brass stud. You can see it isn't very big. It's kind of hard to handle, and I might need a little more thread on that end, I don't know. But I'm going to hold that in there with Loctite right up to the end of the thread. But before I do that, I'm going to lap this surface a little bit. Now you can not machine, but you can clean up all your surfaces by this method, but I don't bother going to that high degree of finish, but I know some of you guys do like to do that. But here's a brand new sheet of 320 wet or dry, and on a surface plate or a true surface, make sure it's clean now, or you're going to feel it up through the paper. But taking your work like this, well, that's going to cut nice. It just feels so nice, even though it's 320. And a figure 8. Until you get the finish you want. I'll do just a little more. And that gives you a pretty flat surface. Make sure you don't rock this. And that's the purpose of the figure 8. You could put oil on there too, but I don't think it's necessary. That's as far as I'm going to take it, because that surface was not milled. If you try to clean up a surface like this that has milling marks on, that's going to take quite a bit more, and you want to start with a little bit coarser sheet than 320 and then work your way up to something fine. But before I do that, I think the next step is I'm going to put those chamfers on here. So let's step over to the mill and do that now. I'm over at the Bridgeport mill. Be sure and watch my video where I show you how I make this pedal operated spindle brake. Incredibly handy because it allows me to make my tool changes without dropping the tool, that is the chuck or whatever it is, because I got one hand on my wrench and the other hand on the tool, and my foot on the brake, so I do not drop the tooling. So watch that video, because I really enjoyed this, and I just built that recently, and it was in the planning stages for years. Cable operated. Again, I'm going to put the chamfers on the cylinder, and there's so many ways of doing that. You can tilt the head using a regular end mill, and And you could hold that in different ways depending on which way you want to tilt the head. But I'm the kind of guy that would rather take a beating than tilt the head and then have to tram it back in. So the way I like to use is my end mill that has the 45-degree corners on it, and that's how I'm going to do it today. And I'm just going to machine it so that it's about 3/16 of an inch across that chamfer. I'm not nearly there yet, but I can use my little stubby ruler and measure across the flat. And after I get the dimension I want, then I'll take the work out and flip it by 180 degrees, and that way I'll get the exact same size chamfer on the other side, rather than moving the cutter over here and then having to reset everything and attempting to get them exactly the same. I'll do the rest of that off camera, and I'll take my last pass by climb milling rather than conventional milling, and I like the finish that I get.